Thank you, PVG. Thank you very much, and good evening, everybody. It's an enormous honor and indeed a great pleasure to be here today to address all of you in such an esteemed set of experience here. So I'm really looking forward to sharing some thoughts that I have on the semiconductor industry, the way the industry behaves. Then I'm going to take you through the lessons that we took at CSR for our company, but I also think that some of these lessons are probably applicable broader and could serve as a model for indeed a country such as India. But before I do that, so talk about the semiconductor, our vision within that, and then Q&A, I'd like to start with a story. And this is a real story that I experienced. It's called The Doorknob and the DVD Player. And this is a story that I came upon when I was living in Silicon Valley. And we owned a house in Cupertino. We had a very nice, beautiful front door. But at some day, my wife decided that the doorknob of that front door wasn't shiny enough. So she said to me, Joep, I don't like this front doorknob. Why don't you go out and buy me a new one? So, a good husband as I am, I complied. Went to the Home Depot. I'm sure so many of you know that shop. And I went doorknob shopping, which was a first for me. So I walked through the aisles and I looked at the doorknobs, and there was various models, and I settled upon a very nice, heavy brass doorknob. And it was really thick. It weighed about ½ kilo. It had a doorknob on the inside, on the outside. It came with a triple security lock, with 3 keys, with a nice shiny handle on both sides. You had one of these levers to open it up, and a drawing to explain to you how you should mount that. $99, I was very proud. This is a fantastic doorknob. My wife's going to be very happy with me. So as I walked towards the checkout, I stumbled upon one of these displays, and on sale was a red laser DVD player. And being a technology guy, I said, okay, let me check that out. So there's a very nice, it was before Blu-ray existed, red laser DVD player. As you know, these things have an LCD screen which indicates what is playing and where you are on the track. It has a nice drawer mechanically coming in and out. The optical pickup unit, and I used to be at Philips, I know this is precision technology with a lot of firmware, hundreds of thousands of lines of code. Every line of code, by the way, as we all know, costs about $10 to write. It's governed by thousands of patents. A lot of PhDs have worked on that thing. And then on top of that, there was 2 DVDs from Disney to throw in to get the kids excited, plus a manual in about 15 different languages, this thick, that also had to be written. The price, $59.95. So here I stood with my doorknob, which is zero technology, for $99, looking at the red laser DVD. And for me, still today, it struck me. It's the metaphor for how this industry, through innovation, is taking something that at some point was at least $1,000, and a short period later is now $49 or $59. And the only way to stay in business is to innovate and to make sure you're on the forefront of these new developments, when there's still money to be made, but by the time your red laser DVD is in the Home Depot, you're too late. And this, for me, sums up what this industry is all about. That's why I like to say it's to innovate or to disappear. Now, back to the semiconductor industry. If you look at how large it is, just the fact it's about $300 billion. That is actually not that big. $300 billion is about 0.4% of global GDP. However, and this is one of the things that earlier before this meeting we had another meeting where we talked about this. There is a massive multiplier effect of semiconductors in the economy in general, which means that it's extremely important for countries, for areas to have a semiconductor industry because it's so innovative and because of the multiplier effect on the industry. But in itself, if you narrowly look at the semiconductors itself, it's about a $300 billion industry. We all know this, but I always like to remind everybody, It's about innovation. And innovation usually gets translated in the ever shrinking size of a transistor. Now, and we've seen many of these in 1970, when you could fit in a typical musical hall about 2,300 people. If this was a semiconductor world, then today you'd fit the entire population. This is an Intel slide, by the way. It says China. I should have put India. 1.2 billion people in the same music hall. That is how small it's all become. This is the humble silicon atom. This number is 14 in the periodic element table of elements. And the size of a silicon atom is 0.234 nanometers. Really, really small. Now I've got a question for you. If you now look at the line width, the process nodes as it's called, of the semiconductor industry, today we are the leading edge at around 22 nanometers. The number at the bottom of this slide, 94, is actually the number of silicon atoms that you have in the width of one line. Think about it. You have less than 100 atoms, and this is printing technology, don't forget. So to give you a sense of how minute this has become, and how little room there is going to be left for us. I mean, you cannot go much lower than another factor of 10, because when you hit one atom, you're done. Now the reason I make these points, because they're well known, I know that, is because this innovation has profound implications on why the industry behaves the way it does. And it's translated in cost. So the first thing you're dealing with, if you think about semiconductors, and you look at this slide here, you say, okay, what about a cost for a fab? We earlier talked about the ambition of India to enter the wafer fabrication technology industry. You look at this, if it's a 130 nanometer fab, you need to invest about $1.5 billion. But for the leading edge today, if you decide, and you have, of course, you need a lot of know-how and stuff as well. If you decide, hey, I'm going to build a fab that produces these 22 nanometer nodes, so that means I can print lines with 100 atoms in diameter, you better prepare to fork out $6.7 billion. And oh, by the way, on top of that, there's a process that you need to develop, and that'll cost you another 1.3. So we're talking about round numbers, around $8 billion just to get the fab in. And of course, the companies that do that, TSMC, Intel, Samsung, they do that because they want to make a return on investment. So the implication for companies like CSR, fabless semiconductor companies that outsource the manufacturing to these foundries, is they're going to charge you for that. So that means if you do a chip design cost, which includes the overhead that you're going to get charged by the foundries in 22 nanometers, you're talking about an investment of about $150 million. Where if not that long ago, when I joined CSR, as PVG mentioned, in 2007, our node was 130, we were moving to 90, you were talking about $15 to $20 million investment here. So this whole notion of the innovation and the ever-shrinking node has profound implications on the structure of the industry, on who can play, but also has profound implications for companies like CSR. We're a $1 billion company, medium-sized semiconductor company. So we need to think about, if we want to do a chip in 22 nanometers, we need to invest $150 million. Wow. So the next step of that is, okay, good, let's assume we do that. Let's assume we make that investment. Now, you can do some analysis. You say, look, let's assume you have 2 years per node, per 22 nanometer node, or per 32 nanometer node. You have 3 players for every application that compete. And you need 3 ICs per player in order to be credible in a specific market. Then you can do some calculation and can say, okay, how big does the market need to be to actually accommodate 3 players that all invest $150 million in every chip for that market. And the interesting dynamic that emerges is, at 90 nanometers, the TAM required for the market to sustain 3 players with 90 nanometer products is about $720 million. And there is about 31 of those. So you can find 31 markets with a TAM of $720 million, where 3 players can compete and all be profitable. Well, you can understand where I'm going with this. Of course, as the nodes shrink and the investment gets bigger, you need much bigger TAMs in order to sustain the players if they want to be profitable. And if you're talking about 22 nanometers, you need a TAM of about $4.5 billion, and now we're down to about 13 of these markets, which is why you see this massive competition in smartphones. Because smartphones is one of the few markets today where you have a TAM, actually the TAM in smartphones, if you put all the silicon together, is more like $20 billion. So $20 billion TAM, leading edge technology, all these chips, baseband and application processors are all at the leading edge. So if you want to play in that market and you're a semiconductor company, you better be prepared to invest $150 million in every single product that you develop in order to compete there. So what do you see in smartphones? You see Qualcomm, you see Intel, you see Samsung, you see Broadcom, you see Marvell, you see Spreadtrum, you see RDA. I mean, it is an extremely competitively intense market. Fundamentally, because if you want to play at the advanced nodes, there's just a few markets that will sustain you and give you a chance to recoup your investment. So, very, very brutal business, if you like, with profound implications for a medium-sized company like CSR, but also profound implications for anybody who is not already at this huge scale to say, hey, this is an interesting market, I want to get to multiplier effect, so I want my economy to be part of this because there is this multiplier effect on the rest of the industry. And then the question is, well, do you really want to start out by investing $8 billion in the leading edge fab competing in the smartphone market with TSMC and Samsung? I'm not so sure, but we'll get hopefully to some answers later. One more point to make. It's a slightly different angle, but this is a McKinsey analysis which I found absolutely fascinating. And it looked at about 400 companies that had a very good growth rate. Because at the end of the day, if you want to survive in this business, you need to grow. So they looked at an overall sample of 400 companies and then split between telecom and high tech. And this is not just semiconductors, by the way. It's high tech companies, so it's broader than just semiconductors. And they said, okay, so these companies were very successful in growing. They grew with, on average, 10% per year over a period of 5 years. So that is sustained growth. How did they do it? And they said there's 3 ways, 3 buckets. The first bucket is what they call portfolio momentum. Portfolio momentum means you're in a market with a leading position and the market is growing. You're a number 1 or a number 2 player and you've got a tailwind. That's